Continuing 1.2, we're going to look at matrices in reduced row echelon form and also in just row echelon form. This is actually probably the most important concept in this class. In Calculus 1, you learn how to take derivatives and then you use derivatives to do practically everything. It's the same way with this. We're going to learn about how to put matrices into reduced row echelon form, and we will use that for basically, well, almost every problem that we solve the rest of the semester will somehow involve it. The idea is reduced row echelon form, it's the best form a matrix can be put in for pulling the answer out. So, for example, if you had a system that has a unique solution, the reduced row echelon form is going to be one where you can just read that solution immediately off of it. But let's look at the definition. All right, it's in row echelon form if any rows consisting of all zeros are at the bottom. In each row that doesn't consist of all zeros, the first non-zero entry is a 1, called the leading one. And if you have two successive non-zero rows, the leading one in the higher row is farther to the left. So what you get is this sort of stair-step thing. This example says, determine if each matrix is in row echelon form, and if it is, determine if it's in reduced row echelon form. We'll talk about reduced in just a moment. But basically, all of these that have the pink on them are in row echelon form. And if we look at it, let's see, only this one has an all zero row and this one. And those all zero rows are at the bottom. All the other rows have as their first entry, their first non-zero entry is a 1. If we look at it, that's true for all of these things that are highlighted. And for two successive rows, the leading one in the higher row is farther to the left than the one in the lower row. So basically, your leading ones, if we were to come through here and circle them, they're always sloping downward from one side to the other. So let's see, here, 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 here. And let's see, this one, F, we've got a column of zeros there in the beginning, but it's that's fine. So those are in those pink ones are in row echelon form. What about B and E? Why are they not in row echelon form? Well, the problem with B is we've got a zero row in the middle. For this thing to be in row echelon form, that zero row would have to be at the bottom. And over here, this is the problem on E. We've got a 2 there, and the 2 is the first non-zero element in that matrix, so that's not in row echelon form. Let's see. These others, are the others in reduced row echelon form? Well, reduced row echelon form just means that if a column has a leading 1, then everything above and below that leading 1 is 0. So if we come back and look at all of these, I'm going to put an X next to these two because they're not in either. Let's decide if these are in reduced row echelon form. For A, we've got a 2 here that's in the same column as the leading 1, and we've got a negative 1 there in the same column as the leading 1. So this is in REF, but not reduced row echelon form. All right, C. Oh, we've got a... No, C is fine. This 5 had me concerned for a second, but that 5 is fine because it's not the first... there's not a leading 1 in that column. So that 5 is no problem. The 2, though, and these things here, those are non-zero elements above a leading 1, so therefore that's in REF. Now D, if we look at it, with the leading ones, everything else in all those columns is 0. So this one is in reduced row echelon form. And ditto for F. It's got leading 1s here and here, and everything else in those columns is 0. So that's reduced row echelon form. So a couple of facts about reduced row echelon form. Every matrix can be put into reduced row echelon form using the elementary row operations. And if we go back up here and look at these that are not in reduced row echelon form, what could we do to them? Well, this one, if we just multiplied this middle row by 1/2, that would put it into row echelon form, because it would change that 2 into a 1. And this one up here, it'd be even easier to put into row echelon form. You just want to swap these two rows. And if you wanted to put one of these, let's look at this. If we wanted to take this and put it into reduced row echelon form, all we do is take multiples of this row, and add on to that. That would get rid of the 2. Then we could add multiples of this onto the top row to get rid of the 1. So we can always use these row operations to put a matrix into row echelon form and then into reduced row echelon form. So fact here, every matrix can be put into reduced row echelon form using the elementary row operations. And furthermore, if you start out with some matrix over here, if you put it into reduced row echelon form, there's a definite answer you're going to get there. There might be more than one path to get from the original to the reduced row echelon form, but whichever path you follow, you're going to get to the same place. There's a unique reduced row echelon form of any given matrix. So what I want to do is talk about how to put matrices into reduced row echelon form, and we'll look at that in the next video.